Good day. My name is Shoaib Shoaib Ahmed, Nation ID FJP70I. Today, I'm presenting the third and final video task for the course Technical and Economic Fundamental of Vehicle Development. This assessment focuses on the steering, suspension, and braking system of a passenger vehicle, conducted as part of the 2025-26 academic year at SZE Banigaitam. Our evaluation is divided into three critical subsystems. First, the steering system, where we assess the mechanism type and driver control. Second, the suspension system, focusing on stability, damping, behavior, and comfort. Third, the brake system, which is our primary focus for safety, performance, and oil verification. We begin with a thorough steering inspection. This includes measuring steering wheel free play with the engine running and identifying the system type, such as this rack and pinion design. We are also performing a hydraulic check of the pump, reservoir, and V-weld tension while using the road test to evaluate turning circles and ball joint noise. Technically, the rack and pinion system converts rotational motion to linear motion through tie rods and steering knuckles. I'm inspecting the rubber boards for any tears that could lead to component failure. To ensure accuracy, we utilize diagnostic tools such as steering play gauges, hydraulic pressure tester, and infrared thermometers to monitor fluid temperature. Turning to the suspension, we first classify the design. This Audi feature a MacPherson strut configuration in the front, which is space efficient and combines the shock and spring. We are also identifying if the vehicle uses double wishbone setup for superior handling or standard coil spring suspension for improved ride control, comfort. The inspection proceeds from the engine bay, where we check strut mounts and breeches, down to the wheel well to examine shock absorber, steering, and dust boats. During the dynamic road test, I am evaluating the damping behavior of the sprung mesh and listening for any pivot point irregularities or uneven surface. The brake system overviews identifies both disc and drum components alongside safety aids like AVS and ESP. We check engine bay parts such as the vacuum brake booster and master cylinder sealing. For safety reason, performance verification is strictly conducted in safe, open areas to avoid endangering other road users. To provide precise data, I'm using a micrometer to ensure the brake pads exceed the 3 mm minimum safe thickness. I'm also checking the rotors for leaf formation and surface scoring. Finally, we test the brake fluid for water content and boiling point to verify it meets the required duty specification. A comprehensive wheel assessment involves identifying rim materials, in this case alloy wheels, and checking for any corrosion or damage. For the tires, I'm documenting the DOT manufacturing date and measuring tread depth at the TWI marks. We also use a gauge to verify the tire pressure matches the specified levels for each axle. During the road test protocols, I'm evaluating steering responsiveness and the vehicle's return to center field. We monitor the suspension for body roll and shock absorber effectiveness on rough roads. Lastly, we verify braking performance, ensuring straight line stability and testing the holding power of the parking brake. To remove subjectivity, I have utilized professional grade equipment including micrometers with plus minus 0.01 mm accuracy and brake fluid testers. I am also using belt tension gauges, TPMH calibrators, and vacuum gauges to check the booster system integrity. These instruments allows for a data-driven report that meets professional standards. To conclude, this inspection provides a holistic view of the Audi's steering, suspension, and braking health. Our findings on wire patterns and alignment help establish a clear maintenance schedule and preventative service intervals. The vehicle currently provides a solid foundation for safe operation through continued maintenance. Thank you for your professional attention.